Today we will discuss about the mechanics of rocket propulsion. In the last video, we have discussed about the thrust force. When a system is losing mass at constant rate and that mass leaves that system with some constant velocity, the thrust force is given as m dv dt. We'll write it as a thrust force. That is the rate of losing mass minus dm dt multiplied by the velocity at which this mass is leaving the system. That is Vr, the relative velocity of the mass which is leaving the system, the original system. Okay. Now this is very similar to a rocket propulsion. How? We'll see that. Suppose this is a rocket. At time t equal to 0, the velocity will be equal to 0. Now it is losing mass, so in the downward direction with rate dm dt, or we'll write minus dm dt, and it is ejecting this mass with velocity of vr with respect to the rocket, and as it will launch vertically, its weight will act downward. That is, its weight is suppose mg, and at any time, let's say its velocity is becoming v and its mass is becoming m. So if the initial mass is m naught, we'll consider at t equal to 0 the mass is m naught. And this is at time t. Now what is the thrust force for the rocket? At any point of time, if mass is m, if it is accelerating upward with dv dt acceleration, the thrust force it is getting due to the mass ejection, that is minus dm dt into vr, that is going to get applied to the rocket in the upward direction because it is losing mass to the downward direction. And so net force upward is this one minus the downward force. It has to overcome the weight of it, that is a net upward force, and that net upward force from the Newton's second law, you know that it is mass into acceleration. So we write mass into dv into dt. Now see, in this equation we'll divide everything with m, so we'll get what? Dv by dt will be equal to 1 by m dm dt will be minus vr minus of g. Now dv will be equal to dm by m, that is minus, into vr minus g into dt. Now we can integrate it. So initial velocity suppose is u and final velocity is becoming v at any point of time. Initial mass is m naught, it is becoming m at some time t, and the time integration is 0 to t. So what we will get by integrating dv? V minus u is equal to dm by m, integration is ln m, and the limit is m naught to m, and there will be minus vr minus g dt is 0 to t is gt only. So you can write that v minus u is equal to minus vr ln m by m naught minus g into t. So v, we can write that v equal to u minus gt, and this minus will take inside the log, then it will be plus vr log of m naught by m. So this is the velocity at time t if the initial mass is m naught and at any point of time mass is m. So this is the equation of the velocity of the rocket. Now see, in this equation, if the initial velocity is 0, we'll put u equal to 0. If we ignore gravity, then g also we can ignore. If the thrust force is very high compared to its weight, then we can ignore gravity as well. So we can write G also will ignore. So we'll make Z 0 only. So in that case, we can write that V is equal to this all parts will be 0. So we can write that V equal to VR, the rate of mass ejection, that is equal to into ln of m naught by m. So this is our equation of velocity if we neglect the gravity, and this is the actual equation of rocket propulsion. I hope you understood till this point. We'll discuss about some problems in the next video. Thank you so much.